All right, good afternoon, ladies and gentlemen. Welcome to another series of tutorials with me, Aubrey. In this lesson, we are still doing the ECZ, GCE, and GCSE playlist. This is where we'll be revising for the exam, the GCE exam. So if you've not already subscribed to the channel, please subscribe to the channel. If you are subscribed to the channel, the subscribe button should be gray. So if it is red, it means that you've not yet subscribed. So leave a comment on what you would like to see in the next video. I will share my email in the description so that if you have any question, you send it to my email, then I will be able to do a video on that. All right. So yeah, but you can bring out suggestions on the questions that you feel you need help with, and I'll be here to assist. All right, so this is physics. Let's dive in. All right, so question 1 reads, let me just zoom in. So question 1 reads, the diagram shows a pendulum. So this is the pendulum. It has a bob. So this round thing here is the bob. So what you should know about pendulums is that the length of the wire is counted or is measured from the midsection of the bob to where it is tied there. So that is how we measure the length of the wire. So it's from the midsection. So these are questions that you have in other papers. So you'll be given maybe a bob like that. So you're given a bob, then they tell you to say this is the diameter. The diameter is so much. So, and this is so much. So find the length of the pendulum. So the length of the pendulum will be from there to where the bob is connected. All right. So that is just a side note for you. Now for this question, we are looking at the movement of the pendulum. So the pendulum moves from 4 critical points. These points are called 0 points because it is momentally stationary at those points. So at this point where it is starting, it is initially starting with zero acceleration, all right, or zero energy or zero velocity. Then as it goes down here, when it reaches the middle, the acceleration or the velocity starts reducing. Then when it reaches this point B, which is the perpendicular point to the supporting beam there, again it reaches 0. Again, as it starts increasing, it will reach a midpoint where again it will start reducing until it reaches another 0 point. Then it goes back like that. All right, so if we were to think of the pendulum in these points, so when the pendulum moves from point A to point B to point C back to point A, we say that it has one oscillation, which is just one period. Okay, which is one period. So a period is the time taken to complete one oscillation. Okay, so when it moves from A to B to C back to B back to A, it has made one period, which is just one oscillation. So now looking at it from A to B, it moves 1/4 of the period. From A to B, the time it will take, it is 1/4 of the period. Again, from B to C, it is 1/4 of the period. Then from C to B, it is 1/4 of the period. Then again from B to A, it is 1/4 of the period. Okay, so it is just 1 over 4 times the period, 1 over 4 times the period. So moving from A to B, 1 over 4 times the period. If you are told to find the time taken from A to B to C, so it will be this time plus that time. If you are asked to find the time it takes to move from A to B to C back to B, it will be this time plus that time plus that time. So that is how you approach the questions. All right, so we look at our question. So given that the period of the pendulum is 1.6 seconds, so 1.6 seconds, let's write, all right, given that the period is equal to 1.6 seconds, find the time the bob takes to move from point A to point B. So from point A to point B, it is just 1/4 of the period. So from A to B is just equal to 1/4 of the period. Okay, so which is just 1 over 4 times 1.6, which will give us 0.4 seconds. So that is the time it will take to move from A to B. If we're asked to find the time it takes to move from A to C, from A to C, that will be this time plus that time. So it will be 1 over 4 the period plus 1 over 4 times the period. So you just plug in the period there and there, then you add. So if you are told to move from A to B to C back to B, to just be, so A to B to C to B, it will just be this period plus that period plus that period. So that is how you approach this question. So for us, it is just from A to B, which is 0.4 seconds. So this looks like a 5. Let me write it properly. All right, so that is seconds. All right, so which is D. Okay, we can move on. What is the volume of a 900 grams of a substance whose density is that much? So volume is what we're looking for. We know that density is equals to mass over volume. So making volume subject of the formula is just as simple as cross multiplying here. So we cross multiply this times that, it will be volume times density. Then this times that, which is just equal to mass. Then we want volume, so we divide both sides by density. By density, we remain with V here, which is mass over density. So we just plug in our mass and our density. But when plugging in your mass and your density, you need to be very careful. Your mass in terms of the units should be the same as your density in terms of the units. What I'm talking about is this. For instance, we have 900 grams, meaning that in the density there should also be grams. So if this was 900 kg, then here we have 15 grams. We would have to convert 900 kg to grams for us to use it. Okay, so for instance, if this was 900 grams and here we had 15 kg per centimeter cubed, it's either we convert this, so they should have the same units. That is my main point. So since they're already having the same units, so this is 900 grams and this is 15 grams per centimeter cubed. So the mass will be equal to 900 grams divided by the density, which has 15 grams. Okay, so this is giving us 60 centimeters cubed. Just follow other units here for the volume. All right, so but I'll show you in the next video how to simplify the units, but you just follow the units that are there. That will be all. All right, so we move on. We are on question number 3. All right, so question number 3: a person of weight this much at the bottom of the mountain climbs to the top. The gravitational field changes from this at the bottom to this at the top. His mass is unchanged. So this is very important. This is what you should know about mass. Mass does not change. Mass here on Earth is the same mass on Mars, it's the same on Pluto. Your mass will never change, but your weight changes. Okay, so you have to put that in mind. All right, so he has mass which is unchanged. What are the masses? What are his masses and weight? Or what are his mass and weight at the top of the mountain? So there is this person. I'll draw my mountain at the bottom of the mountain. Okay, this person, first of all, the gravity at the bottom is 10 newtons per kg. Okay, then this person has a weight of which is 600 newtons. Then what else have we been given? All right, so we can find his mass at the bottom of the mountain. So first of all, let's find his mass at the bottom. So we know that weight is equals to mass times gravity. So we put in our weight, which is 600 newtons, will be equals to the mass, which we are looking for, times the gravity, which is 10 at the bottom, meaning that we divide by 10, the 10 here and there cancels, so meaning that our mass will finally be equals to, so 600 divided by 10, which is just 60 kg. So you put your units for mass, which is 60 kg. So mass, the units are 60 kg, so that is 60 kg. All right, so this person decides to go on top of the mountain. Okay, his mass is unchanged. Okay, so the mass still remains 60 kg, so because mass does not change. Then the gravity that we've been given is 9.97. So we are looking for the weight at the top. So weight is equals to mass times gravity. Our mass is 60 kg, or we just write the units. 60 times our gravity, which is 9.97. So punching that on the calculator, we have let me see. All right, that is 60 times 9.97. that is giving me a weight of 598.2. all right, so that is what we have. So now the question is, what is his mass at the top? So the mass at the top is 60 kg. So we have two 60 kgs. We don't know which one is which. Then we have 598.2. So 598.2. So this is probably the best answer, A. So A is our best answer. All right, let's do one more last question before we go to the next page. The question reads, a list of physical quantities is given below: weight, energy, force, mass, and acceleration. Which of these are vector quantities and which of them are scalar quantities? So vector quantities need to have magnitude and direction. Okay, then scalar quantities just have to have needs to have quantity. So for instance, mass is a scalar quantity. Okay, so mass is a scalar quantity. What else is, so just mass is a scalar quantity. Mass is a scalar quantity. So we have mass and energy. Okay, because weight is a vector quantity because it has direction, right? So we rule out this one that says weight is a scalar quantity. We rule out that one. Acceleration and force are not scalar quantities. So here what we have is that weight is a vector quantity, force and acceleration are vector quantities, because weight has force or has mass, which is magnitude, and acceleration, we accelerate in a particular way. Same applies with force. Force has mass and acceleration, mass being the magnitude and acceleration being the direction. So same applies for acceleration. It has direction and magnitude. Yeah. All right. So mass has no direction. That's why it does not change. Then energy arguably has no direction. Arguably. All right. So this is it for today. Have a good night. See you in the next lesson.